In these problems, we have quotients of expressions with exponents. So you can see in this problem, we've got z squared x to the fourth over z to the sixth x to the third, and we want to simplify that. The way to think about this is that, z to the second is z times z, x to the fourth is x times x times x times x, z to the sixth down here is z times z times z times z times z times z. Is that 6? Yes. And then x to the third. Anytime in a fraction like this that you have everything multiplied together, you can go and cancel. So whatever looks the same on the top and the bottom can get canceled. So this x could cancel with that x, this one with that one, this one with that one. And same with the z's, this z with this z, this z with this z. What you're left with is just one x on top and 1, 2, 3, 4 z's, and that z multiplied by itself 4 times is z to the fourth. So the answer here is x over z to the fourth, which is a good deal simpler than what we started with. A shortcut to this is just to subtract. So when we divide, we're subtracting. So this is really like x to the 4 minus 3 power when you take x to the fourth and divide it by x to the third. We kind of go in the other direction here because the bigger power is on the bottom. So in my head, I said 6 minus 2, that's z to the fourth. Let's try another one. This time we won't write it all out like that. So I've got b to the sixth, a to the seventh over b to the fourth a. So this time, the smaller exponents are both on the bottom. And since we're dividing b to the sixth by b to the fourth, it's b to the 6 minus 4 power, which is b to the second on the top. And with the a, we have a to the seventh minus, well, that's a to the first. So it's a to the 7 minus 1 power. That's a to the sixth. So we don't even have a fraction anymore. I mean, that's all over 1, but we don't need to write it that way. It's b to the second times a to the sixth. So that's a little bit of work with these quotients with expressions involving exponents.